So in the previous video we have watched that how when you're placing the second layer what type of your arrangement we were getting, that is from the square close packed layers and that of your from hexagonal close packed layers. So from the hexagonal close packed layers we came to know with respect to the two important types of the voids, that is your tetrahedral voids and the octahedral voids. And now in this video we are going to see that in the above videos we have just see that when you are placing the second layer what had happened. Now you are going to place the third layer in such a way that you are going to cover the voids which you have generated earlier. That is what happens when you are placing a third layer. Remember, a layer means overall a sheet of layer. A layer will be placed. So that will be called as almost a layer. We are not saying a row or something like that. We are saying overall a layer. So now a third layer has been placed in such a way. So there are two possibilities that we will be covering the tetrahedral voids. Covering the tetrahedral voids. That is the empty space which has been generated when four spheres are accumulating. That is, if I take an example over here. So in the diagram we have seen that this is your tetrahedral void. So now when you are placing a third layer in order to cover this tetrahedral void, what would be the pattern of your solids? Remember guys, whenever you are covering the tetrahedral void, what happens? The third layer will resemble to that of your first layer. That is, if we have placed first layer as A. Of course, this is the third layer of placing. We are getting the voids in that of your hexagonal close packed layers. So we know that in hexagonal close packed layers, the pattern were different. That is, A was the first layer, B was the second layer. So now when you are placing the third layer, they are saying that it will resemble to that of the first layer. So you will be getting an arrangement of the type AB pattern. So this is when you are obtaining this pattern, when you are placing the third layer to cover that of your tetrahedral voids. So such pattern when you are observing, this is called as that of your hexagonal close packed structure. Hexagonal close packed structure in 3 dimension. Remember, it is in 3D we are studying. Of course, we have seen the hexagonal close packed structure in 2D also, but hexagonal close packed pattern in that of your 3D is observed when you are placing a third layer in order to cover the tetrahedral voids. At that time, whatever the close packed structure you are getting, that is called as that of your hexagonal close packed structure. Coming with respect to that of your second one, covering the octahedral voids. Covering the octahedral voids. So here is very much important once again. Because whatever the third layer we are putting over the first and the second layer, they say that the third layer is not resembling with any of these two, first or the second layer. So whatever the third layer of putting is completely different and you are getting a pattern of A, B, C. So now the question arises whether this will be continuing. The answer was when the fourth layer was kept. When the fourth layer. So here we are just seen with respect to the third layer. No matters with that, it continues. But when you are covering the octahedral voids, we are getting a pattern. The third layer doesn't resemble with that of your first layer or the second layer. Instead, when you are putting the fourth layer over that of your third layer, you could observe that it resembles to that of your first layer. So you are getting the pattern as ABC pattern. So such close packed structure is called as that of your cubic close packed structure, or is also called as that of your face centered cubic. Is also called as that of your face centered cubic. You getting my point, I hope. So when we saw that from a hexagonal close packing, from when you are placing the second layer, we were obtaining two types of voids, tetrahedral and that of your octahedral. Now what we are doing is we are placing the third layer in order to cover the tetrahedral voids. So when you are covering the tetrahedral voids, we are getting a pattern. The third layer is similar to that of your first layer. So we are getting a pattern of AB pattern. So such pattern when you are obtaining is called as that of your hexagonal close packed structure in 3 dimension. So when you are placing the third layer with respect to that of to cover the octahedral voids, remember the third layer doesn't matches with either of your first layer or the second layer. In turn, the fourth layer what you are putting to cover the octahedral voids, that will be resembling with that of your A first layer pattern. So you're getting a pattern as ABC, ABC. So it is called as that of your cubic close pack or a face-centered cubic. Now, very much important, they can ask you, what do you mean by a face-centered cubic close pack structure? Or what do you mean by hexagonal close pack structure in 3D? So you should be able to say that whenever you are placing the third layer to cover the tetrahedral voids, the pattern obtained or close pack structure obtained, that is called as a hexagonal close pack structure in 3 dimensions. So whenever you are placing a third layer over the top of your octahedral voids and whatever the pattern you are obtaining, that is called as the top of your cubic close pack or a face-centered cubic. So this says that how does your atoms are arranged with respect to that of your 3-dimensional structure. Now the question arises with some calculations, but very much important. So here you have to remember that if I consider a number of the close pack spheres be n, that is how many spheres are there, let us take it as a n, is a general formula which says that the number of the octahedral voids generated will be also equals to n. The number of, if the number of the spheres are n, number of the octahedral voids in that structure will be also n. Whereas the number of the tetrahedral voids will be equals to 2 times that of your n. This is very much important in solving our problems. Further, when you are writing a compound formula, for example, if I am writing as some A4BY, so AX and BY, this X and Y can be calculated with respect to the definition what we have learned earlier with respect to the voids by calculating the number of voids. So before going to that one, let us see that what they have mentioned over here. To write a formula of a compound, a number of the voids filled. Remember, whatever the ions we are writing in this way, okay, whatever the ions or atoms we are writing in an ionic solids, basically, if I consider this one as an ion, so whatever the spheres we are writing, that represents to that of your bigger ions. Generally they will be your anions because they will be of larger size. So when you are writing the structure and you are getting certain voids, that is the space over here, so those voids will be occupied with respect to that of your smaller ions, usually that of your cations. So what they are saying, anions will be generally be that of the spheres what you are writing, whereas the cations are generally used to cover those voids. This is very much important. So if the cation is smaller enough, they say that the tetrahedral voids are occupied. If the cation is larger enough, it occupies your octahedral voids. In a given compound, remember that all voids are not filled, but it depends upon the chemical formula of the compound. So in my next video, we are going to see with certain calculation part. I hope so it have been understood. Once again, I will just give a quick revision. So when you are placing the third layer to cover the tetrahedral voids, we are getting an hexagonal close pack structure. When you are placing the third layer in order to cover the octahedral voids, you are getting a cubic close pack structure, is also called as that of your face-centered cubic. In a simple way, in order to calculate the number of voids, if n is the number of the spheres, okay, n is the number of the spheres, then what would be the number of your octahedral voids? Of course, n will be the number of your octahedral voids. Whereas 2 times of the n will be your number of your tetrahedral voids. Now, whenever we are writing an ion, yes, larger anion will be representing that of your bigger ions in an ionic solid, which forms your close pack structure, whereas that of your cations having the smaller size will be occupying the voids. Okay, if cation is very small, it will be occupying a tetrahedral void. If it is somewhat large, it will be occupying your octahedral voids. So in our next session, we are going to see how to calculate that of your formula.